Chiara.
And I'm Kat.
And we are here to teach you about physics from nothing.
Today we're going to explain to you what escape velocity is. So let's start with this ball. You know that as I throw it, it's always going to come back down into my hands. If I throw it with a little bit of energy, it goes a little bit. But if I give it a lot of energy, it goes further up before it comes back down.
So do you think that Kat can throw this ball with enough energy that it can escape the gravitational attraction of the Earth? This is something called escape velocity, and this is what we're here to teach you today.
So this is our model of how gravity works. So here's us on the Earth. When we put the Earth in space, it bends space around us. So you can see all the space is bent around the Earth. Now here's the ball again, obviously not to scale. And as I throw the ball up from the Earth, I give it a little bit of energy and it climbs up this well a little bit before it falls back down. Now if I give it some more energy, it can climb further up this well before it falls back down again. So that's all that's happening when I throw the ball up, is it climbs up the well and then it falls back down. Up and down.
So it's not just the Earth that bends this fabric of space and time, but anything that has mass, you, me, or the sun does the same thing. But obviously the sun is much more massive. It actually contains 99% of all of the mass in our solar system. So it's no wonder that the well that it makes is much, much bigger than the one that something like the Earth makes. And this is why the Earth rotates around the sun like this. The Earth is just following the path around the well and is slowly and gently circling around the sun.
So escape velocity is just how fast something has to be moving to escape the gravitational wells that we just showed you and not fall back down.
That's right, and so the Earth is a lot lighter than something like the sun. So it takes a lot more energy to escape the gravitational pull of the sun.
So the escape velocity of the Earth is 11 kilometers per second, which means I'd have to throw the ball at 11 kilometers per second for it to escape the gravitational pull of the Earth and not fall back down. Now that's 360 times the UK national speed limit, which is really fast, and I don't think I can throw the ball that fast.
The escape velocity of the sun is 600 kilometers per second. Now that would be like traveling from Birmingham, where we are now, to Durham and back in 1 second. So if you found this really interesting, but really easy, stay tuned for our next video, which goes into a more in-depth explanation of what we talked about today.
Bye!
Bye!